Hello friends, welcome to Coding Host YouTube channel. In this video, I will explain you program to convert decimal number to octal and octal to decimal number in Java. Before writing the program, first we have to learn some basics. So decimal numbers have base 10 because decimal numbers consist of digits 0 to 9, which are this. After that, octal numbers have base 8, which include digits 0 to 7. Let's take an example that we have a decimal number like 100 and decimal numbers have base 10, and we have to convert this number in a octal number, so which has a base 8. So we have to convert 100 into a octal number. So let's see. So this is our source number and this is our destination number. So we have to divide the source number with the base of the destination number. So source number is 100 and its base is 10, and the destination number is we have to find, and its base is 8. So 100 here and dividing it by 8. So 8 into 1 is 8, and we get a remainder 2 and this 0, so 20. So 8 into 2 is 16, and after that we will get a remainder 4. Now we have to again divide this number. So 8 here, 8 into 1 is 8, and we get a remainder 4. After that 8 into 0 is 0, and in the last we will get remainder 1. So we have to take all the reminders until the source number will not become 0 in the end. Now we have to multiply all these reminders with the base of the source number and its powers. So 4 into 10, and its power will start from 0. After that, next remainder multiply by 10 power 1, and then next number will be multiplied by 10 power 2. So now here we will get 10 power 0 is 1. So 4 into 1 is 4. After that 10 power 1 is 10, and 10 into 4 is 40. So 40 here. After that 10 power 2 is 100 into 1. So 100 into 1 is 100, and we get 100. After that we have to add all these numbers, 100 plus 40 plus 4, and after that we will get 144, which is the octal conversion of 100. Now let's take another example that we have a number 144 in which is an octal number, and we have to convert this number in a decimal number. So let's see. Source number is 144 and its base is 8, and the base of the destination number is 10. So we have to divide the source number with the base of the destination number, which is 10. So 144 dividing by 10. So 10 into 1 is 10, and 10 into 4 is 40, and we will get a remainder 4. After that 10 into 1 is 10, and we get a remainder 4. After that 10 into 0 is 0, and we get a remainder 1. So we have taken all the reminders until our source number will not become 0. Now we have to multiply all these reminders with the base of the source number, which is 8, and with the power of the base number starting from 0. So 8 here, and its power is 0, and next reminder multiplying it with 8 power 1, and then next reminder multiplying it with 8 power 2. So 8 power 0 is 1, and 1 into 4 is 4, and we get 4 here. Now 8 power 1 is 8, 8 into 4 is 32, and we get here 32. After that 8 power 2 is 64, and into 1, so 64 into 1 is 64. So after adding all these numbers, 32 plus 4 is 36, and 36 plus 64 is 100. So in the decimal number we will get 100. Now let's write the program. So in the program, first I will take a variable int n, and in this I will pass our number 100, and then I will take a variable int base 1, and in this I will pass the base of our source number, which is 10, because it is a decimal number. And then I will take another variable int base 2, and in this I will pass 8, because we want to convert the number in a octal number which has a base 8. After that I will take a variable int d equal to 0. So in this variable we will store our destination number, and after that I will take one more variable int a equal to 1. After that I will take a while loop while n not equal to 0, and in this I will write int r equal to n modulus b2, and d equal to d plus r into a, and a equal to a into b1, and after that n equal to n slash b2, and in the last we will print our destination number. So in this I will write d, and let's run the program. So we are getting 144 in the output, which is the octal conversion of 100. Let's take another example that we have a octal number 144, and we have to convert it in the decimal number. So its base is 8, which is the source base, and the destination base is 10, which is the base of decimal number. So let's run this program. So we are getting 100 in the output, which is the decimal conversion of 144. So let's see how this program is working. So in the program I have taken a variable int n equal to 100, and it is the source number. So I am writing here n, and its value is 100. After that I have taken a variable base 1, which is the base of our source number. So here p1, and its value is 10. After that I have taken variable base 2, which is the base of our destination number. So base 2, and its value is 8. After that I have taken an entity variable to store our destination number, and its initial value is 0. After that I have taken a variable int a, so a, and its value is 1. After that I have taken a while loop while n not equal to 0. So here you can see value of n is 100, which is not equal to 0. So our condition is true, and we will get inside our loop. So int r equal to n modulus base 2. So we will divide n by base 2, and we will take out the remainder, and I will store that remainder in the r variable. So let's see 100 here, and dividing it by base 2, which is 8. Now we get 4 in the remainder, and storing it in the r variable. So now this r variable has 4 inside it. After that d equal to d plus r into a. So value of r is 4, and value of a is 1. So 1 into 4 is 4, plus d, which is 0. So 0 plus 4 is 4, and assigning it back to d variable. So now this d variable has 4 inside it. After that n equal to n slash b2. So we will divide n by b2 and take out the quotient and store it back in the n variable. So we will take out this quotient and store it back in the n variable. So now this n variable has 12 inside it. After that a equal to a into base 1. So a is 1, and base 1 is 10. So 10 into 1 is 10, and assigning it back to a. So now this a variable has 10 inside it. After that we again run our loop. So n not equal to 0, the value of n is 12, which is not equal to 0. So our condition is true, and we get again inside our loop. So int r equal to n modulus b2. So we will again divide n with b2 and take out the remainder. So n is 12, and b2 is 8, and now we get 4 in the remainder and storing it back in the r variable. So now this r variable has 4 inside it. After that, d equal to d plus r into a. R is 4 and a is 10. So 10 into 4 is 40 plus d, which is 4. So 40 plus 4 is 44, and assigning it back to d variable. So now this d variable has 44 inside it. After that, n equal to n slash b2. So we will take out this quotient and store it in the n variable. So now this n variable has 1 inside it. After that, a equal to a into p1. So a is 10 and p1 is 10. So 10 into 10 is 100, and assigning it back to a variable. So now this a variable has 100 inside it. After that, we again run our loop. So n not equal to 0. So n is 1, which is not equal to 0. So our condition is true, and we again get inside our loop. So int r equal to n modulus b2. So n is here and dividing it by b2, which is 8, and now we get 1 in the remainder and storing it back in the r variable. So now this r variable has 1 inside it. After that, d equal to d plus r into a. So r is 1 and a is 100. So 100 into 1 is 100 plus d, which is 44. So 100 plus 44 is 144, and storing it in the d variable. So now this d variable has 144 inside it. After that, n equal to n slash b2. So we will take out this quotient and store it back in the n. So now this n variable has 0 inside it. After that, a equal to a into p1. So a is 100 and p1 is 10. So 100 into 10 is 1000. So now this a variable has 1000 inside it. After that, we again run our loop. So n not equal to 0, but here you can see value of n is 0, which is equal to 0. So our condition is false and our loop will break, and after that we will print our d variable and we get 144 in the output, which is the destination number. And the use of this a variable is that it is storing all the remainder digits in their right place. So first digit will store on the 1st place, and then second digit will store on the 10th place, and then next digit will be stored on the 100th place, and so on. So this is why we have to use a variable with initial value 1. If I take another example that I want to convert 144 to the decimal number. So in the int n variable I will pass 144, and in the base 1 variable I will pass 8, and in the base 2 variable I will pass 10, and the remaining procedure will remain same like I have explained you here. So this is how we can write a program to convert decimal number to octal and octal number to decimal in Java. Thank you.